Here we have an x-axis origin here. We have an initial x value here, and we double that x value. And that's going to give us an x value about here. Now that's not done perfectly. You can see that this interval is a little bigger than this interval. They should be the same size, but that's simply the way the chalk behaved in my hands, okay? So it's the chalk and it's me. Anyhow, so this distance then would be duplicated here in order to double this x value. And this distance duplicated here to double this x value. And this distance duplicated here to double this x value. Alternatively, we could have started out here, and there are a lot of times we might want to do that, and we can simply cut each x value in half. This point is as close to the origin as it is here, if I've done this correctly. This point is as close to the origin as it is to this point. And from this point, and the origin are equidistant. From this point, and this point are equidistant. So we can continue having these values as long as we don't get so close that our chalk lines merge. Okay, so what we have is, as x increases, x values double. And that's equivalent to, as x decreases, the x values halve. H-A-L-V-E, not H-A-V-E, halve. Okay, now here we're going to do a y-axis, and we want to change y by a constant factor. Now let's back up and say changing x by factor 2. Okay, that's equivalent to doubling x. Between this x value and this x value, the value changes by factor 2. That is, it doubles, and we've seen that terminology. Here we want to change y by a constant factor, and for example, we're going to change y by factor 3. So we start with a y value, and we triple it. So is this distance 3 times this distance? It looks like maybe I went a little too far, but it's not implausible. Okay? And this distance, if this distance is 100, is this distance 300? And then if I want to triple this again, well, that's going to be up here someplace, so I'm not going to label that. So here's the origin, y equals 0. Here are a sequence of 3 tripling x values. I attempted to draw another one in here by cutting this down to 1/3. It was a little difficult to draw that. The chalk didn't come out where I thought it was going to. I could have done what I did over here. I could have started with y up here and taken 1/3 of that value. In other words, if this is 300, is this 100? If this is 300, is this 100? Various ways to see that. Or alternatively, this distance again and again. Looks like maybe this should be up a little higher, this should be a little lower, but this is a reasonable approximation. Okay, so what I have here is I have again y tripling and x doubling. Now I then match up the points in pairs. I match this point with, and I chose this point, not this one. There's no rule that says you got to choose the first point you come to. But once you've chosen a point, once I've matched this point with this one, then I have to match this point with this one, because from here to here y triples, and from here to here x doubles. So match this point with this one, draw a point. Match this point with this one, that gives me a point about here. Now, as looking on the monitor, I see this point's a little low. Looking over here, this point is a little too close to the y-axis. It's not quite exactly above this one. Looking at it at a bad angle. In any case, I get these points, and if I draw a graph, I get a curve for which y triples when x doubles, at least a hand-drawn approximation to that curve. I'll observe that the curve is kind of imperfect. I kind of went off on a straight line here and failed to curve properly. And the graph could have been drawn much more accurately. I also note that if I keep cutting x in half and keep cutting y in a third, I get closer and closer to the origin 0, 0. And it's clear that no matter how close I want to be to the origin, if I cut x in half enough times, cut y in half enough times, I can get that close. So it makes sense to kind of extend the graph a little bit by including the origin. Now, if you double 0 you get 0, and if you double it again, you get 0. Also, if you triple it, you keep getting 0. So that 0, 0 doesn't really satisfy the condition that y triples when x doubles, because you can't really triple or double 0. You can, but not really. Not in the sense that we want to think of it. Okay, now, I call this the tripling graph. I can also call it the factor 3 graph, because the y factor is 3. Y triples when x doubles. We're always going to have x doubling, at least right now. For this class of functions, x will always double. So whatever y does is going to be the characteristic of the graph. We could construct a factor 3.5 graph or a factor 0.7 graph. A factor 3.5 graph, we would more than triple. So if this is one x value, we would more than triple to get that, and then we would more than triple to get the next y value. We'd use factor 3.5 instead of factor 3. Or we could use factor 0.7. Now that's going to cause y to get smaller, because 0.7 of any y value is smaller. That's perfectly legitimate. Okay. When we construct a graph with a constant y factor as x doubles, it's going to give us what we call a power function. Now there's a formula for a power function, and usually that formula is where we start. But remember, note that these graphs don't have any scale here. There's no 1, 2, 3, 4, 5, 6. We could put a 1, 2, 3, 4, 5, 6 on it, and same with the y. We could put them anywhere, and we would still have the power function. Okay, we'll see that as we go on, but we call these power functions. And the basic idea is that whenever y changes by a constant factor when x doubles, our graph represents one of these power functions. And the graph of any power function has this characteristic. That is, has the characteristic that whenever y changes by some constant factor when x doubles, that any power function has a characteristic that y changes by some constant factor whenever x doubles. I've written this statement up here. The power functions are an extremely important class of functions. Many, many real-world phenomena can be modeled by power functions, and we're going to see that. You should be able to construct a doubling on the x-axis, okay, a set of x values that double, or a set of y values that triple or quadruple or change by factor 3.5 or factor 0.7. You should be able to do that without measuring things and without having a predetermined scale on the y-axis. You should be able to do that approximately visually.